Okay, it's the top of the hour. I'm just going to start things off here, and thank you all for joining. I know there are going to be some more people joining, but we don't want to wait for too long because we've got a great hour of good content. So let's get started. Thanks for joining today's Resilient Connecticut webinar focused on climate vulnerability in New Haven and Fairfield counties. I'm Katie Lund, CIRCA's Director of Engagement. For those of you who are able to join one of our workshops this winter on climate vulnerability, this will be a bit of a follow-up on flood aspects of a new tool we're going to demonstrate and show some progress we've been making in terms of the flood vulnerability. But we're also going to be showing new results for heat vulnerability and introduce some concepts and methodology for wind. So we've been working very closely, CIRCA has, and our team, with our consultant team, and we are fortunate to have 3 speakers with us today. We have both David Murphy and Victoria Vetre from Malone & McBroom, and we also have Johanna Greenspan-Johnston, who is here with us from Dewberry Consulting. Before I turn it over to David Murphy to start things off, just a few mechanics to mention. I am recording the webinar, so if you want to pass on a link that will email everyone after the event to any colleagues of yours who might be interested, we'll make that available. And you're all muted, but you can ask questions of our presenters throughout the event by entering your questions in the chat. You just type your question, press enter, and then we'll all be able to see them. And we're happy to, answer questions as we go. We're going to start by focusing in a little bit on heat vulnerability, and then we'll take a break and answer some of those questions if you have some particular to that tool. But we'll try and, keep going to the schedule. And if you can't use the chat button, we prefer that you use that, but there's also a Q&A option. So we'll be monitoring both throughout the morning here. So David, I'll start by turning it over to you. And we appreciate your willingness to kick it off today. Thanks.
Thanks, Katie. Okay, so I think what I'll do is jump straight to the agenda. So we'll have a few minutes of overview slides that I'll run through. I'll turn it over to Victoria to talk about the heat-related part of the tool, and then she'll give us an update on the flood-related tool. And then we'll have a chance to look at heat and flood combined in a program called Tableau. Johanna from Dewberry will take us through that part of the webinar. Then we'll go back, talk about what we've done with wind. I'll give you a little introduction, then we'll kind of end with next steps, questions and answers, and we will have chances for question and answers throughout as well. So don't worry, if you have a question, we'll get to it. We won't miss it. Put it in the chat box or in the Q&A, as Katie noted. So real quick, just right off the bat, the purpose of the webinar is to describe the updates to the planning tools and kind of show you some interesting observations and examples of trends that we're seeing. We will not dive into the details about how each index is calculated. So if you are a person who likes math, today might not be for you, but hopefully, you can catch us offline and we can go through the equations with you some other time and talk about exactly how indices are calculated. So just real clear that we're going to keep it high level and look at things that we think are cool and not talk about the equations too much today. So what is the Climate Change Vulnerability Index? And from this point on, I'm going to call it the CCVI because it is a mouthful to say that every time. So this is a tool that's been developed for New Haven and Fairfield counties that can be used for planning and project development. And I have a map there just to remind all of you that we are working throughout the 2 counties. That's how federal funds are oftentimes dispersed. But the towns that are in gray are not going to be going forward for the heavy TOD oriented planning that's happening later on. So all the towns in the 2 counties, all 50 some towns, have been analyzed through the CCVI, and we'll look at some examples in the next few minutes. So what else can I say about the CCVI? So it builds on the coastal index that was developed by CIRCA, and this is an image that I'm sure many of you have seen before. You've also probably seen it on CIRCA's website. And whereas that tool relied on a grid throughout all the coastal towns, our tool moves inland and focuses on Fairfield and New Haven counties. So as I've implied, it's an index that aggregates different things like sensitivity, exposure, and adaptive capacity. And the tool brings together a lot of different data within each of those three categories, sensitivity, exposure, and adaptive capacity, to help us visualize patterns of vulnerability. It's really important to note that vulnerability scores are relative to the region as a whole. So we're not attempting to quantify a risk, right? Many of us know that risk, we need to look at frequency and consequence to characterize risk fully. So if you're looking at vulnerability scores in this tool, we're kind of implying a risk, but we're not quantifying the risk. And I guess what that all comes down to is you're not going to see this tool suddenly pop up in Zillow, right? We're not here to assign a risk to a parcel or to a property. We're really just talking about relative vulnerabilities. But that's really important in and of itself. So why is it part of the resilient Connecticut planning process? So a couple things that we can assume. We can assume that an index of vulnerability is kind of a suitable tool to view patterns across a region. And we also can assume that an index is worthy indicator of where to invest resources to address climate-induced risks. And so we can use these tools to help define opportunities for projects that will make the region more resilient to climate stressors. So it really just comes down to two things, those final two bullets here. The CCVI can help us advance the planning needed for this project, but it also can be used for future types of community and regional planning. And that's the hope, is that this will kind of live on. And if you remember this this graphic back from the summit and from some of the workshops in January, we're really working within this middle part of this task 4, which is identifying the challenges part of this Resilient Connecticut project. So the tool is helping us recognize and characterize the challenges. Okay, so that's why, that's what the tool is and why we're doing it, but why flood, heat, and wind as opposed to other hazards? Well, we believe and we know, we understand that the conditions that cause flooding, such as intense precipitation and coastal storms, are known to be affected by climate change. And we also have a better understanding that's developing of how heat is affected by climate change. It seems obvious, but sometimes the urban heat island effect is something that's harder to kind of get our arms around. And then the one that's a little bit harder to characterize is wind. We believe that severe wind has always been a challenge in our forested state for many years, but we also believe that climate stressors may lead to more severe wind events. So those are the three kinds of hazards that we're choosing to focus on in the CCVI. And the status of each is that the flood portion is pretty well developed. It was reviewed during the workshops back in January and February. The heat version is pretty well developed. We're going to talk about that in a few minutes. And then we've really just gotten into the wind CCVI. I would call that preliminary at this point in time. By the way, those graphics are courtesy of FEMA. I did not make those myself. So with that, I'm going to turn over the controls to Victoria. And let's see if I can do this right. Go. Right.
Okay. Thank you very much, Dave. Okay. So like Dave said, we're going to kick this off a little bit with the heat discussion. The workshops a few weeks or months ago, I guess now, we did focus a little bit more intensely in flooding. So we'll focus a little bit more on heat today. Not too much, but a little more in depth. So this is also the first time I think I've presented in Zoom in the past year without a PowerPoint. So let's see how it goes today. So we have sensitivity, we have exposure, and we have adaptive capacity. So those are those three components that are going into each of the CCVI. So we have heat, flood, and wind, right? So when we're talking about sensitivity for heat, you want to think about those populations that are a little more sensitive to those extreme heat, events or those extended periods of extreme heat. If we're talking about built sensitivity, we might be talking about, say, things like structure age, older homes, less insulation, less updates, so not quite as energy efficient. We might be talking about those homeowners that rely on private wells, so they don't have the capacity to kind of monitor their water levels. If we're talking about exposure, that's more of the degree that those sensitive components are going to be exposed to. So exposure, we'll call those climate and physical exposure. So again, in the context of heat, we might be thinking about climate exposure as land surface temperatures or air quality. For those physical exposure components, we would talk about impervious surfaces, so the density of our impervious surface distribution, emissivity, so talking about how how our structures and how our built infrastructure is radiating heat across the region. And then some adaptive capacity, right? So how well how well can our communities cope with heat and with extreme heat events. So if we're talking about some of our social adaptive capacity, we might be talking about emergency communication systems. So how well we can communicate, with residents and throughout neighborhoods, how prepared our demographics are. So we're looking at health insurance, how we can cope with, with the impacts of extreme heat and those health impacts associated. A few ecological factors. So we have the Normalized Vegetation Index, NDVI. So looking at the health of our vegetation across the region, our percent tree cover, right? So where do we have shade? And then we have albedo. So when we're looking at, what types of land cover are absorbing or reflecting heat. So those are just a few of the heat specific components. So what we're looking at now, this is the viewer that we will be launching. So we had a slightly different viewer. Again, if you joined us at the workshops, a slightly different viewer. This is more of a kind of a final format. Hopefully, if you did join us in the workshop, you see some aesthetic changes that we've made. So let's talk a little bit about some of the heat results. At first glance, you could see these darker areas. Really central around our urbanized, more developed areas, which I assume most people are like, okay, that makes sense, right? We have these higher impervious areas, these densely populated, urbanized areas. Those are kind of those heat zones. But there are some smaller spots throughout the region that, that I do want to highlight, right? There's some surprising areas. So let's see if this works. I'll jump over to my bookmarks here. So one of the first areas, and most of these you'll see are also kind of centered around our, those TOD, these train station areas. So these are the areas that I'll focus on a little bit today. However, once we do have this viewer tool up and live, you can run through the same process with an area that, you would like to look at a little bit more. So if we're looking at the smaller area in New Canaan, it's a smaller hotspot in comparison to some of those other larger ones. So what's going on here? Most folks wouldn't think that New Canaan is a hot spot or, urban heat island, but there are some, what's going on in this smaller area. So if we want to take a look at, these darker red squares, which are kind of, insinuating higher heat, if we want to take a look at this chart, so let's go over to our heat vulnerability. We're going to draw a nice little polygon around the area. And we're going to take a look at a chart. I know folks during the workshops were really questioning what's going on in the area, what's going on in the area. So it kind of pulls up and shows us what exactly is going on in New Canaan, and we can compare this to other areas. So right off the bat, we see we kind of have this higher exposure. We have higher climate and higher physical exposure. So, we don't have to you don't have to keep exact mental note of all the numbers and, just trying to show some of these trends, right? So we're looking at this New Canaan area. We know that it's higher exposure. Some of these sensitivity levels aren't quite as high as maybe some other areas, but okay, this is useful information. So, it's good to know that if we're going to be looking at a project in the New Canaan area, we want to be address some of these physical and these climate exposure, which might be air quality, emissivity. We might be looking at impervious surfaces and things like that. So, okay, that makes a little bit of sense. But if we shift over to another area, so let's go back to my bookmark. We'll jump over to a marsh area in Guilford. So this looks pretty similar, same coloration as the smaller New Canaan area. If we were to do the same process and take a look at what's going on at this marsh area, I know myself and most others would think, well, it's, there's no construction, there's no development. What are we seeing here? So if we go through, like I said, we'll draw a nice little polygon around our marsh area. And again, we have the train station over here. Let's take a look at what's going on in this marsh. So, okay, climate exposure, physical exposure. So how is this marsh area comparing to the same as, the smaller, New Canaan area? Well, that's when we can start to dig into things a little bit deeper. This is kind of the beauty of the CCVI. So there's a lot going into it. But once you really start digging, you can see, you can see those factors that are contributing to, Actually, I did sensitivity. Let me do exposure here. You could see these factors that are contributing and driving this number up here. I guess I can't multitask, draw and talk at the same time. There we go. Okay, so we've got our climate exposure, or excuse me, our overall heat exposure. So now we can dig a little bit deeper into what's going into the exposure at the marsh area. So climate and physical, we've got our two top scores here, and then all of those subcomponents are these sub-contributors going into it. So it looks like we have a little bit of a higher air quality. So this higher rank, number 4, means it's a little bit more exposed. So this is on a scale of 0 to 5. So 5 being more exposure. So we have higher emissivity and some maximum land surface temperatures. So again, this sounds odd because it is a marsh. However, these areas with reduced tree canopy that are primarily water, they are in fact emitting a little bit higher heat. So interesting to note that it's comparing the same as a more urbanized, well, I call New Canaan urbanized, but in relation to a marsh area, it is a little more urbanized. But this is something that might jump off the map and folks might say, well, why is the marsh heated? So just want to point out some of these kind of surprising results, right? Let's see, try to keep going through this as quick as I can. I had this all planned out for much longer than I have. I always do that. So here's another area that I wanted to take a look at as well. So if we're looking at Fairfield, Bridgeport, Stratford, it looks like this entire area is heat vulnerable, right? One could almost clump it together. But once, again, you take this CCVI and you start digging into it, you can start to kind of block off what's going on in each area. So if we were to look at the exposure or the sensitivity and all of those individual contributors, what's going on in the Fairfield area compared to, say, Bridgeport or Stratford, there might be some small differences here. So I will take a look quickly at Fairfield and Stratford. We'll just compare the two quick. Actually, I do Fairfield and Bridgeport because they're next to each other. So if we look at the vulnerability surrounding Fairfield train station. All right, so let's see. So we've got our higher climate exposure, higher physical exposure. So overall, our exposure in this area is about 3, so kind of a moderate exposure. And then we have our sensitivity scores. So again, those are demographics, those are our populations, those are our built components of the system. So we've got about 2.5, right? So if we were to jump over and take a look at how that compares to Bridgeport, and I know I'm kind of moving quickly here, but there'll be a few minutes for questions and hopefully I can clarify something. If we take a look over at Bridgeport, see how those numbers compare. So our exposure numbers are a little bit higher, right? So we've got a 4.7 and a 3.9 for climate and physical. So that might, again, be saying, okay, we've got a little bit more maybe impervious surface. Maybe the emissivity is a little bit higher. And we also have some slightly higher numbers for social sensitivity, and built sensitivity is about the same, but social is a little bit higher. So, okay, so that was a lot of graphs, a lot of numbers. To wrap it all up before I open the floor to questions really quick. So like I said, the beauty of the tool is that while areas do look, like we have got these larger swaths of, say, in this case, heat vulnerability, once you start to really dig into those contributors and take a look at, those numbers of each factor, we can start to tease out what's going on and what we need to address. Maybe it is social sensitivity, maybe it's built sensitivity. We can look at the, I'm going to say strengths and weaknesses of that community and of that certain area. So looking forward, what we'll be doing, and Johanna will start to kind of tie some of this together, for the Resilient Connecticut project, we'll be looking at the more analytics of this, but for users and for folks who might want to be using this, every day for planning or, project identification purposes, this is a great way to identify what components of the system in the area that you're looking at, are strong, where you can keep building on, and those areas that, we might need to address. So some contributors in here, for example, are distance to shelters, distance to hospitals, vehicle access and, transportation capabilities. So then we can start to kind of make those longer term plans in addressing those, those sensitivities and those certain levels of exposure. Let me see here. So I am at 10:20. So I can open the floor, and I don't know if there's any questions or anything right now that I can address for heat. If not, I can roll into flood. Let me see here. Chat, Q&A.
Yeah, Victoria, I don't see
Yeah.
any questions yet.
Okay.
And, you know, everyone, we recognize this is a lot of information and kind of a very technical tool, but, you know, I think that it's just important to note that this is kind of a work in progress, and I think we're also thinking about ways to provide guidance and in terms of how to use the tool. We will make it available to everyone online as a link if you want to just go in and kind of mess around and play with it a little bit too, and just post webinar. Check it out on your own, but you know, this kind of just serves as a bit of a demo, and we really were curious in terms of any kind of questions you have. So a reminder that in terms of your questions, there's like a little conversation chat bubble. That's where you enter them throughout this hour. So we'll keep monitoring those. And Victoria, I guess I don't see any coming in. So yeah, you can continue on. Oh, here we have one.
Yep.
What range of heat are we talking about?
Right. So I'm not exactly sure if I'll answer this correctly, but let me know if I do or don't. So we're not talking about any certain range of heat. So we've included some factors such as, so the land surface temperatures is the, I will guess, land surface temperature, and emissivity is the other one. I couldn't think of the word. So those are the two contributors that we have. Mariana, and I forget her last name.
Fragamini, yeah.
That's it, Fragamini. I was like,
Yeah.
I know, it's a mouthful. I love that last name though. So Mariana at UConn, they've developed a few heat-specific layers. So we've been working closely with her team. So they've developed emissivity and maximum land surface temperatures that we've been looking at based on satellite imagery. So that way we can identify the areas that have been, you know, previously had high temperatures, extreme temperatures, and then those areas that are continuously, you know, they have higher levels of heat radiation, you know, emitting heat. So we looked at, go ahead.
Yeah, and just a note, I guess, also from one of our team that this is really looking at the last 5 years of the land surface temperature.
Right. Okay.
There is a question in terms of seasonality or versus hourly, like the resolution, I guess, of the data. I don't know if you can answer that one, Victoria.
The resolution of the data, you know, I'm not sure about that one off the top of my head. But thank you for pointing out that it is, you know, the data that she's derived, right? It was from the past 5 years, so in recent.
Yeah. And
right.
we also have, for those of you that are particularly interested in this project, we just mentioned one of our research team members from UConn, Mariana Fragamini. She provided a full hour-long webinar earlier this September, and you can go and watch that webinar about heat vulnerability in a pilot project in New Haven. And so, you know, if you're kind of interested in this topic and how heat is kind of measured using sensors, we do have a separate project going on about that. And Mariana's actually on the line, and she has been answering some of the questions too. Hi, the data resolution is 30 by 30 meters. Yeah, so in terms of the resolution. But yeah, I'm looking back up. There was another question related to that. Oh, seasonally versus hourly. Yeah, we'll have to see if our research team, unfortunately, they're not unmuted, but maybe we can answer that as we go along further in the webinar. Right. I'll check in with them.
Right. I was going to say the CCVI itself, this index itself, does not take into account any sort of seasonal or hourly variation. But again, these are great questions. So Mariana again is on the line, so she might be able to throw something in the chat for us to help answer that. If there are any sort of seasonal variations with the emissivity or the land surface temperatures. But no, the index itself is just focused on, you know, kind of a snapshot in time. So not necessarily seasonal or hourly, but these are good questions.
Yeah, and following the webinar, I will put a link to that that previous event in the follow-up email to all of you too. So you can find that and watch a little more information on that particular pilot project that we have in New Haven County, or New Haven with Mariana. All right, so we should probably move into the flood section, which some of you might have, again, seen on a previous event that we've had. And you know, I think the flood tool has been kind of demoed and is a little bit further along. So we'll show some of that, and then show a tool that kind of combines heat and flood, because one of the questions was, I'm looking back up through here. One of the questions earlier was, are we developing an index of vulnerability such as low to high? So I think some of this, the combining of heat and flood and looking at the overall tool in terms of an overall vulnerability, we'll get to as the webinar progresses. So I want to make sure that the person that asked that question knows that we're going to get to some of that information. Right. So. Okay.
Yeah, and Johanna will talk a little bit about that combined flood and heat, but this index itself does give this kind of overall, you know, so the heat map that we were just looking at is kind of an overall heat, taking into account the sensitivities and exposure plus the adaptive capacities. So if you look actually, so I've got the flood up on the screen, but it's similar for heat. You know, we have this 0 to 1 scale. So 0 being the least, according to the CCVI, the least vulnerable, with 1 being the most vulnerable. You know, so for each index, you know, there are, I don't know, maybe 30 to 40, you know, contributors going into that. So based on all of the ranks, you know, 1 to 5, we've kind of, you know, crunched all the mathematical numbers, like Dave said. If you like math, we're not going into that too much today, but we do have that overall score based on, you know, based on all of those rankings of each contributor going into it. So, all right, so let me just touch on flood really quickly. We got a lot of great feedback from those workshops, so we just wanted to highlight a few of the, changes, and I won't go into it. I say as in depth as I did with heat, but I really didn't have much time to go too much into heat, but that's okay. So a few of the notes that came out of the workshop, a lot of it was aesthetics and kind of user friendliness. So hopefully we've captured a lot of that with what we are. What I'm showing today. Another note that came up was, really capturing these flood zones. So once we started digging into, flood vulnerability, we realized that, the way we've put our FEMA flood zones into this gridded index wasn't truly capturing the flood risks, or, what communities were actually experiencing on the ground by way of flooding. So let's see here. So I thought I had, there we go. I believe this is the area. So one example that came up was Fairfield. We really weren't capturing the flooding in that floodway area of the FEMA flood zones. So we went back, we took a look, we reassessed our rankings for that. This new map is really capturing the the floodways and the flooding, and hopefully more capturing, what communities are experiencing as a whole. So if we see here, we've got our flood zones, and all of these darker cells are those that are, considered, this is overall flood vulnerability. So it's not just FEMA flood zones. There's a lot of other contributors going in. We've got our sensitivities and our adaptive capacities as well. But we're really excited that, Fairfield pointed this out. And so we're really capturing the flooding that's actually happening, going on in the ground, and these risks that some communities are actually seeing. Some other examples, we talked about, including bridges and culverts to talk about debris. So we've combined that suggestion with the North Atlantic, I always forget this acronym, the North Atlantic Aquatic Connectivity Collaborative, so the NAC data. We've included that to help us identify, impacted stream crossings, or, blocked stream crossings. So we're hoping to kind of capture that ecological sensitivity, but also, looking at potential, blocked culverts and, reduced or exacerbated flooding due to, impacted and reduced connectivity on our streams. And then another one was historic resources. So this is, I pulled up this area here. So let me just turn these flood zones off. So we've got an area in New Haven, right on the West River here. So you can see this area in the center of the screen. Hopefully everybody can see my pointer. I won't go into the graph just because that's a lot, but you can see here we've got our historic resources, which is a 5. So that's part of our built sensitivity, right? So a lot of our historic structures and our historic resources, you know, they're not flood proof the way some other structures are in our flood area. So this is a good example of, you know, an area nested on a river with a flood zone, with a few historic resources in the surrounding area. So you can see a few of these 10-acre grid cells here do have historic resources. So we're really capturing that. You know, a lot of our communities pride themselves on their historic resources. So we wanted to make sure to capture those as well. Let's see. So those are a few of the flood modifications. Again, I'm not going to start clicking and going into all of the results the way I did quite with the flooding. But you can really see that the, you know, the overall results are really closely aligned with our flood zones. Similar with heat, there are a few pockets of, you know, maybe the darker blue kind of flood vulnerable areas. And again, this is when this tool is, you know, really useful. We can start to look at what's going on in that area. Maybe it's soil drainage properties, maybe it's areas of, you know, lower elevation. So maybe there's potential for pooling or poor drainage flooding and things like that. So it may not be, you know, right in next to a flood zone, but there might be some other flood, you know, flood prone factors going on in that area. To stay with the time, I will pause there. That wasn't too much, hopefully. If there's any quick questions, I can answer those. If not, I can pass them over to, I can pass the control over to Johanna, and we can start to talk about Tableau. So while I do that, I can see
Yeah,
if
and
there's
while you're doing that too, we
question.
did get a general question about
Yeah.
whether there's going to be kind of a glossary or more information about each of these factors that go into this. And the email I sent prior to the webinar to everyone had a fact sheet. The back side of it showed all the different factors that are going into these tools, but there's not a definition as part of that. So emissivity, for example, the amount of heat that's kind of reflected from an object, those are examples that we're going to be putting on our website that kind of has a glossary of terms and some of the source information that goes to that. It looks like you've passed the ball to Johanna, so that's great. And just for those of you that are looking at the chat, to answer one of the questions about the heat that was asked earlier in terms of the seasonality, we're fortunate to have Mariana Fragomeni, who is the PI for one of these projects focused on heat, and she did answer that in terms of it's not a seasonal evaluation of the data, it's more of a yearly and overall look at the temperature based on an annual time frame. We do have a couple questions regarding flood, Victoria, that I'll just focus in on here. Is there any clarification on if the flooding is the result of heavy rainfall versus coastal flooding versus a combination? So maybe if you could elaborate a little bit on terms of the information going into the flood.
Yeah, so it's one of the tricky things with the index is that we haven't necessarily done a lot of modeling to try to, you know, identify which areas are prone to what. So this review that I gave quickly of the tool is a high level kind of those final results. But what we can do is, you know, or what you can do, or I can do, or whoever can do when it's released, you can dig into every single layer and identify, you know, what's going on in that certain grid cell. So we do have, you know, we do have storm surge layers. We do have sea level rise projections. We do have the FEMA flood zones, and we also have, you know, we've developed these pooling areas based on elevation, right, to try to find those little sinks, you know, throughout the region. So this would all fall under exposure, right? So all of these flooding contributors would drive our exposure score. So some of these areas that may have an exposure score of say 1 or 2, there's likely only 1 or maybe 2 factors going on there. If we were to look back at the flooding map and look at the coast, a majority of the coastline is pretty dark, right? We have a combination of those flooding factors, right? So we have, you know, maybe areas are in the storm surge area, maybe they're in a VE zone, you know, they're in the projected sea level rise area, you know, maybe they're along a river, so they're being captured in a FEMA flood zone. So within that one cell, you kind of have that intersection of all of these, you know, flood, I'm going to say models, but they're, you know, like I said, we're not modeling, it's these flood spatial layers, right? So we haven't taken all of this available data and pushed it any further. It's basically this kind of landing pad for all of this data to capture what's going on in that 1 10-acre grid cell, and then what's going on in those neighboring grid cells, and kind of expanding from there. So hopefully that answers that a little better.
And also a note from our Assistant Director of Research, Al Pargonat, who's on the line, that we're also incorporating rainfall using the FEMA zones. So I think that's an important note too. We need to maybe move on to Johanna here. I guess the last question I think that is maybe important to think about is before we move on is the question about whether we're looking at I guess the person who asked called them sensitive receptors, but I think they're critical facilities in terms of senior centers, public housing, schools. So that has come up on previous workshops and events that we've had, this question about critical facilities and how they're related to this vulnerability information. So can you just describe how that's brought in, these critical facilities and the distance to some of those as part of these tools?
Yeah, so we have a full critical facilities list that we've identified those critical facilities that are in a flood area, special flood hazard area, those that are outside. Every critical facility that we've pulled from hazard mitigation plans and local resources, the COGS have provided data as well. So we've pulled from a range of data sources and put together this critical facility. We've identified those that are in the flood zones. So every facility is captured in the CCVI, whether it is in a flood zone or if it's not, right? So basically, if it's present, we're ranking it, but if it's in a flood zone, it's a little more sensitive to flooding. And then when we're talking about the distance to some of these areas, we've developed a few different drive sheds to identify residents that are in certain zones. So if we're talking about a distance to a shelter, we want to know, those residents that are within a closer zone to a shelter, they're a little more adaptive. If there is an emergency, they can get to that shelter a little bit faster than, some other zones. So this way, communities can identify kind of these pockets of, we'll say, outskirts, right? So they're the furthest from a shelter, the furthest from medical care. So maybe this is a great recommendation for a future shelter location, or maybe I'm going to say hospital, but those don't just pop up overnight, right? But taking a look at kind of these areas that are outside of these adaptive zones. So yeah, we develop these kind of mile drive sheds, how long it'll take you to drive there. So we did try to capture all of the the broad range of critical facilities presence and flood vulnerability or flood sensitivity rather.
Okay.
So
let's turn it over to Johanna to look at how we might think about combining some of these climate stressors. And Johanna, you've shared your screen, so thank you. And we'll just turn it over to you here for a few minutes.
Okay, great. Thanks, guys. So what you're seeing right now is a viewer from Tableau. So while we're crunching a lot of this data, incorporating all of their spatial data in ArcMap, ArcGIS, and then you see in the web viewer ArcGIS Online, we're also at the same time putting it into this program called Tableau that is primarily for more data analytics and taking a spatial, or still taking a spatial approach. We're also able to now kind of expand and do a little bit more kind of analytics and review of the data. So as we're moving from sort of scoring and ranking to characterization and classification and better understanding really the relationships and the patterns that we're seeing emerge after we do this processing. So this is right now just an kind of internal tool, and as we're exploring these capabilities, but we'll look at what comes next in the future iteration. So right now you can kind of just see this is vulnerability, flood vulnerability. We can zoom in to look at particular COG or so you can get a better view. We can look at flood. We can look at heat, similar to what Victoria showed. We can get a breakdown of what are the main kind of contributing factors between exposure, sensitivity, adaptive capacity, and also zoom in to really like map those particular elements. But the one thing where I want to, that's particularly useful is being able to go from just the basic viewer to something where we're, let's say, looking at flood and heat combined. and we're getting a map that's looking like this. So it's a little overwhelming, a lot of color, so we're going to break that down a bit. So here, just zooming into a single community like Greenwich, we're, not sure if this is just on my screen. Okay, there we go. So looking at this from a kind of multi-dimensional perspective of combining heat and flood, and the areas where, kind of to walk through it, if we just look at flood, you get kind of low flood vulnerability, moderate, and high in the really coastal areas. Oh, sorry, flood. And then also heat vulnerability, the areas that are low heat vulnerable, moderately heat vulnerable, and high heat vulnerable. So in this kind of multi-dimensional axis. And then this gives us a sense of being better able to characterize, maybe if we're looking at a specific project, and we're looking at a project over here might be, really focused more on, it's an area that's fairly high heat, high flood and moderate heat. So that might be a different type of project that you would do in an area such as this one. That might be a lot more high heat with a range of, with also some high flood areas and a kind of range of scores this way. We're also able to graph, so this is the raw scores, and while the scores that we're mapping for each of the subcomponents is 1 through 5, when we're looking at exposure time sensitivity divided by adaptive capacity to get our ultimate vulnerability score, that's where we get scores that are higher than 5, even up to some extreme high vulnerable areas here that have scores, up to 12. And so you can really better drill down on what are those high vulnerability areas and what is driving that type of vulnerability, to better characterize what we're looking at. And I think that this, as we're looking at our zones of shared risk and identifying areas for specific projects and better able to understand, what's driving the risk, what's driving the vulnerability, and therefore better able to identify what types of interventions and mitigation options are most suitable. One more thing to kind of preview on this note is kind of looking, again, not just drilling down between flood and heat, but between maybe the different factors contributing to vulnerability or any of its subcomponents. So there was a question that just came up, relating to what's driving the flood exposure or the flood vulnerability, and whether you're looking at, coastal factors versus inland factors. So if we're looking at vulnerability, we can map it, or we can, for here, we're looking at flood vulnerability, and those are the colors. So if it's the dark color, it's identified as a more high flood vulnerable area, and can understand what factors are contributing from exposure versus sensitivity. So there might be areas that are highly sensitive. So you have a lot of, vulnerable populations, critical assets, critical facilities, and that might be driving the high vulnerability score in some of these areas. But then you might have areas that are high exposure. So, and those are maybe slightly different areas that are really have the exposure element driving the vulnerability we see. So again, better like zooming in to characterize it. With the question that came up before, we're looking at exposure. We can look at our 2 main contributing elements. So these are already kind of bucketed. For exposure is looking at climate. So that's relating to projected climate change. So future sea level rise and kind of mapped and modeled future projections. And then also physical characteristics. And so with that, we're looking at things like the impervious surface area and drainage capacity. So again, you see areas that are maybe listed as high vulnerability because of the climate factors versus areas that might have higher vulnerability because of the physical characteristics of those areas, and then areas, that fall into both, and those are kind of high, but ultimately end up with the highest exposure scores. So again, another way to sort of, combine the mapping and the spatial views with other types of more traditional data analysis and statistical analysis to better identify the drivers of the vulnerabilities that we're seeing, and characterize that vulnerability to better inform, really decision making overall. So I know that we're a little short on time, so I don't want to keep going into this if we have other things. If we do have other things to get into, but I'd be happy to pause here to answer any questions or show anything in more in depth if people want to see something specific from this view, or from any of the viewers, going back to particularly, I think that's supposed to focus on the flood heat.
Thanks, Johanna. I think it is actually really valuable to see how these tools can potentially be combined to really look at the relationships and patterns. I mean, ultimately, that's where we want to go with this kind of information, is to provide some decision-making tools that can be used in combination with other information to think about some of these relationships and patterns. So that's really useful to have a demonstration of. I'm just looking at the chat here. I know we want to just highlight briefly some of the thinking, the initial thinking at least, for wind vulnerability. So let's turn it back. There are no specific questions to what you presented on, Johanna. So let's turn it back to Victoria, because I think, let's see. Okay, Victoria, you should be in the mode as presenter again. And then we'll have time for questions at the end too. So, all of our speakers are going to stay on the line until the end of the hour. So if you think of some that might be more related to what Johanna just showed, that's great. We did have one general question about whether the data sets that these tools are drawing on are going to be made available in terms of the source information. And yes, we are compiling all of that, and we'll be putting it on the website. Which is the website specifically related to the CCVI tool. And I'll be sending a link to that to everyone following the event too. So we'll just be continuing to update this kind of information and providing the background in terms of the source data. Again, a work in progress, but we'll definitely be making that type of information available too. All right, go ahead, Victoria, thanks.
No problem. So wind is the third CCVI, third index that we've been working on. And in comparison to flood and heat, the data is not quite as spatially friendly. So we've been working on trying to get some of, some historic wind data into a CCVI. So what we're looking at here is overall wind vulnerability. So a lot of the same contributors that have gone into both flood and heat. So all of the same, social sensitivities, looking at some of those demographics, looking at the same built sensitivities in the parts of the system. We also have some of the same adaptive capacity. So when we're talking about communication, emergency communication, we also have factors like disposable income, so how certain areas of the region can, easily rebound and repair after a windstorm. We also have some other factors or contributors. We've looked at wind gusts from, I believe it's 1955 to 2019. So we've taken some wind gust points and interpolated those to try to find the areas that have had the higher wind gusts over the past few decades. We looked at dead ends in communities to try to find those kind of hotspot areas. So, which spots throughout the region have more dead ends. So, access, higher potential for access being limited down those dead ends, whether it's, down power lines, down trees, things like that. We do also look at percent tree cover. So we do have a few layers that are, wind specific. But again, it's been a little bit of a challenge to get some of this, spatial data easily translated into GIS. And I actually did see a question about data gaps, and I think wind really hits home the issue of data gaps. All communities across the state have had issues with wind and the impacts of wind and power outages and down trees. So, it's not confined to any one specific zone, say like FEMA flood zones or urbanized area for urban heat islands. Wind really kind of is a cross-state issue. But if we look here, we see some of these darker areas. So these darker areas are what we're saying according to the CCVI are higher wind vulnerability. So again, this is based on gust patterns. This is based on also aspect, so our topographic facing direction, by looking at, the average wind direction, and trying to map those areas that face that wind direction, right? So they're a little more prone to wind. So you see some hot spots. We have some hot spots in urbanized areas such as Bridgeport. We have some more rural or suburbanized areas such as we've got North and Easton, northern parts of Milford. So a lot of that is based on, our aspect, our gust. So I could pull up a chart, but also we can take a look at a quick pop-up here too of the wind. So we have our social sensitivities here. So number per household, median income, unemployment rates, race, ethnicity, age, education levels, disability. So a lot of this is really helpful in understanding who and how need to be, whether it's warned during an emergency or, educated before an event, letting folks know how to prepare for an event. We have some of our exposure factors up here. So again, like I said, our wind gusts. So this area is a 4 out of 5, so experiences some of the higher wind gusts in comparison to the rest of the region. The aspect is a 5 also, so facing, the average facing direction within that grid cell is facing the direction of the average wind. We have building density, so it looks like this is an area with very little to no development. We have, let's see, median structure age. So it's a little contradictive there because that is a 4, but that makes a really great point, right? Not all of our data isn't on the same scale. So median structure age is based on a tract level, while we have building density, which is based on, building footprints. So there's no building footprint in that grid. However, according to that tract, there's some older age structures. Again, take a look at some of our adaptive capacity, so our disposable income. So this tract, again, is a 1 out of 5. So for adaptive capacity, a 1 means, least adaptive. So this area likely has a lower disposable income. Emergency communications, we have a 4, so they have a great system. Distance to shelter is a 4, so pretty close to a shelter if there was an event. That's right. We also have our state wind speed design standards, so a 4 if we're looking at building design. So these are some of these wind specific components. Again, mapping wind itself is a little more challenging, but I think we've put together a few layers and a few complete. That was like I said, the gaps. A few complete layers that we can best represent, the adaptive capacity of wind events, and also trying to highlight some of those challenges that communities face, such as dead ends. And emergency communications and things like that. So that's a very, very short intro to wind because we are still working on this. I'm trying to get to, let's do that. Very, very short intro to wind because that is the third and the latest CCVI. So we are slowly developing that. We've got some power outage info and things like that. But I think the wind is going to be a very helpful tool in conjunction when we're looking at our zones of shared risk, because that way we can highlight kind of that firsthand experience challenge with wind, taking a look at outage trends and things like that and identifying those in zones, and then also looking at what's going on in the CCVI underneath that zone of shared risk, which obviously we're not covering those today, but I think the wind CCVI with zones of shared risk is going to be a pretty powerful tool. So with that, I know we've only got a few minutes left, so I'll stop sharing, but that's okay because
well,
wind
I
isn't
appreciate you zooming out, I guess, to that regional view. For those of you that are on the line and not familiar with the Resilient Connecticut project, I think because that view showed just these 2 counties, it's worth mentioning to all of you that the reason that this project, the CCVI tool, is focused on New Haven and Fairfield counties is because the Resilient Connecticut project is funded through the HUD National Disaster Resilience Competition, and that money is focused on the Hurricane Sandy impacted communities within those 2 counties. So I just want to make a note that we're hoping to be able to expand these kinds of tools to the rest of the state. If some of you are on the line and wondering why some of these tools aren't showing data and information in your communities. We do have a question that's kind of general, and Dave, before turning it to you, I know you want to provide some wrap up and next steps, but when will these tools and kind of more of a summary be available based on the completion of the work and the data? And so I think that's worth mentioning in terms of the next steps, in terms of the May workshops, because I think people are, this again, it's a work in progress, but when will some more of the summary information be available, and combining some of these impacts or these stressors into kind of one tool. So I don't know if you can make a few remarks on that, Victoria, in terms of timeline, and then we can maybe turn it over to Dave too.
Yeah, I think, after getting a lot of feedback from the workshops and we really kind of dug in and revamped, flood, and took a lot of those comments forward with the wind and the heat, CCVI. So I think going forward, wind and heat might have a few minor tweaks here and there in relation to the Resilient Connecticut project. So I think very shortly, we're going to start to have some of this bring it together information and some of these combinations like what Johanna was talking about, combined flood and heat risks, or I don't want to say risks, vulnerabilities rather. So I think going forward in the next few weeks, we should start to have kind of some of this pull it together information. Hopefully this tool will be launched fairly soon, so folks can start to dig into it. I think once we have our post-webinar meeting of the minds and we agree that it's public ready, we can get this information out. But right, the next steps are project identification, which is what we're using this and the zones of shared risk tool for. So, we're really starting to wrap this part of it up to move forward now to help use these tools to identify those projects. So the timeline is pretty short, I think, is the long of the short of my answer. Should all be out fairly soon.
Yeah, and David, you're going to talk about the workshops in May too, as another thing that's coming in the near future that people that are interested can participate in. So I'll just turn it over to you to sum it up with a few next steps.
Well, that's okay. I think in the time is running short, and Victoria just mentioned this, so I'll keep it really short. We have workshops coming up in May to select potential projects. That's to wrap everything together. I kind of have this crazy graphic that everyone hates, but I love, which I'll show on the next screen, which is kind of just how we're planning to put everything together. So we've really been squarely focused on the CCVI, which is in the center of this graphic. That's what we've been talking about during this last hour. But we've got other things going on, the delineation of the zones of shared risk. We need to use the CCVI to help us prioritize some of those zones of shared risk and then turn them into opportunities and eventually into projects. So that's all coming in April and May. We do not have the dates yet for the May workshops. I'm thinking we'll probably be in like the third week of May, that time frame, so before Memorial Day. But we'll try to get with the COGS pretty soon and set the dates that don't conflict with other meetings that are going on. That's it.
All right, great. And for those of you that don't receive our monthly resilience roundup, that's one of the best ways to keep getting information, not just on this project, but the events that are coming up, because we always put registration for things like this webinar and these workshops. So please watch your inbox, usually in the first week of every month. But if you don't receive that, you can sign up to get our resilience roundup on the CIRCA website. And let me check on Dave. I know thank you for answering some of the questions that were coming in the Q&A in the chat as well, because there were some specific ones there. But I think it's worth mentioning just one of them. Well, we have a few minutes left, because some of the participants had really good ideas in terms of how we might communicate this information. There was one that came in about saying that X% of a town is high risk, or a certain percent of population in Fairfield counties, for example. Fairfield County could be communicated in a way that's a percentage that live in vulnerable areas. So I think that's exactly why we're having this webinar, is to hear ideas like that from all of you as we keep kind of progressing and making these tools more responsive, I think, to some of the information and the needs that all of you have, and to be able to make them valuable in terms of combining them with other decision-making tools. So thank you for all of your input as we've gone through this hour as attendees. We're at the top of the hour. I don't see any other chats, so I just want to close out by making sure to thank you, David and Victoria and Johanna, for continuing to lead us through the demonstration of some of these technical aspects of these new tools. And we look forward to continuing to work with you and engaging the stakeholders that are part of this project now, and hopefully we'll get some more over the next few months with different methods of engagement here. If you like what you see, please join us at some of these upcoming events, and I will be sure to follow up today with the information in terms of the video and some further links, so you can look at those, and please pass them on to your colleagues who you think might be interested who weren't able to attend today. So thank you all. I appreciate your participation and time, and we look forward to having you join us in the future.